So we are going to start with the more basic things to start programming in Python. I have here PyCharm Community Edition, which is a free to use Python IDE. So it's a tool to program which is very useful. I'm going to create a new program here. I'm going to call it 3.py. Py is the extension for the Python programs by default. So this is a comment. This will be ignored, but we can put our comments and will help us to clarify things. So the first thing that I want to show you is print. So if we do like print hello world, then you can execute from command line Python 3.py. Hello world, okay, cool. So print is to print in the screen. So what I'm gonna do is gonna do something a bit different. I'm gonna print a Christmas tree. So that's 1, 2, 3, 4, 5, 6. An asterisk 1, 2, 3, 4, 5, 6. So basically this is it. Okay. One, two, three, four. 1, 2, 3, 4. Okay, correct. Okay, and now the base. Cool. So if we do this, we have our Christmas tree. What happens if we want to print 3 of them? I copied the code, so I repeated the code. I ran it. Okay, you see that there is no space between them. That's because we have not printed an empty line. So I'm gonna do this. Cool. So we have 3 Christmas trees. Okay, cool. But okay, now imagine I want to have a bigger Christmas tree.
Sorry, I don't understand.
So I'm gonna make this bigger. Okay. I think that's fine. So 3 smalls and 1 big, okay. Perfect. So, okay, what happens if we want to put 50 of them? Like having to copy and paste makes no much sense. So let me show first something. One of the biggest advantage of Python is that we can use libraries. So I'm going to import the time library. And what I'm going to do is sleep, which okay, that's fine. That should work. Let me run this. Oh. Another way to do this is from time import sleep, and then we can call directly a sleep like that. Okay. If we want to use, that's for using only sleep, the method sleep. But if we want to use all the methods in time, which are many, we just do from time. Import time. That will grant us access to sleep and as many other methods and functionality, like knowing which time it is. But it needs us to indicate where this method comes. I think we have, okay, another which is for having the current hour. Yeah, this is the current hour in Unix time, which is the number of seconds that has passed since the 1 of January of 1970 in UTC. So that's a value that we use on Unix systems. This is called Unix epoch. So I only want to show you that we can have many functions, simply importing them, and they are built in. So what I'm gonna do is like put a small sleep between those animations, because I want you to see how it progresses more visually. So, okay. Okay, it's a bit fast maybe. We are gonna sleep 1 second. This 0.5 refers to 500 milliseconds. And sleep 1 refers to sleep 1 second. Cool, now it's better. This animation is better. Okay, so if we have 50 like that, what we have to do? To repeat 50 times the code. That's not very nice. Because if I wanted to change this, for example, to make it like that, I have to change so many times everywhere, which is not very practical. So I'm doing now just to show you. But this is not very cool. So what we are gonna do is use what is called a function, and we will call it print small 3. And then we are gonna take this, and we are gonna indent. Indent means that you will have 4 spaces. 1, 2, 3, 4. You will have 4 spaces, and then Python will know that this code belongs to this unit, and it knows because it's indented. If we do like this, if we change this, then this will not belong. Those lines will not belong to print small 3. So we are gonna do this now, and I'm gonna delete the rest. So what happens? If we run now the program, only one big 3 will be printed. Let's show it. Okay, just one big 3. Why? Because we have defined this method, this function, sorry, but this function has never been called. So if we want to use this, we have to call it, and that's calling a function. So now we are going to execute this, and we will have the small 3 and the big 3. Small 3 and the big 3. Okay, I'm gonna clear the screen so it makes more sense. Okay, so now we can execute this 2 times, and after the big one, it will come another small. Remember that we print and we sleep 1 second. Just only after printing one of the small threes. So this will be printed and immediately will be printed one small and then sleep. So let's see it. Small, small, big, small. Cool, that's it. So now if we want to put this in a method, in a function, we create this new medium 3. We put in here. Now we have defined medium 3, and now we have the ability to call the medium 3. I'm gonna remove the sleep from the print function because it doesn't make sense. We want to print. Oh, here the ID is marking me that they have an error, also in here. And the error is just I missed that semicolon. This is called a typo, when you make a mistake like for forgetting one synced or putting the wrong letter. That's a typo. It's different from a bug, which is a generic error. So we are gonna print the small one, print the medium one, sleep 1 second, and print another time the small one. Okay, I clear the screen. Small, medium, small. Cool. So that's why we use functions in order to reuse the code and to simplify it. I want to introduce also a structure for loop, because the code comes like a waterfall, comes from the top to the bottom. The code is executed like that, sequentially, like line 1, line 2, line 3, which is defines it, and then 29, 30, 31. But we have structures in order to iterate and repeat things. So what I'm gonna do is introduce one of these, which is while, that allows us to loop. So what I'm doing here is telling while true. So basically, when we say while, we have to set a condition. A condition could be, for example, while 1 is equal to 1. That will be always true. So it's the same that putting this. And normally we will use a variable. And okay, I will show something. We showed before that we have the Unix epoch time, so I'm gonna take advantage of this. So I'm gonna take the Unix epoch. What the start is equal to time. Okay. And in here, I'm gonna capture another, which is Unix. I will call it epoch, which is more clear. Now is equal time. And what I'm gonna do now is I'm gonna print a small 3. Yeah, I'm gonna sleep for 1 second, and I'm gonna repeat this as long as the time now is smaller than the time when we started plus 10. So basically what I'm telling is, okay, we capture the time in Unix epoch, which are seconds dot milliseconds, and we will capture the time continuously. And we will see, okay, the time now is smaller than the time when we started plus 10? If that's true, so for during 10 seconds, basically, or 9.99 seconds, that will be true. So we will be having the threes printed. Let's run this to demonstrate. CLS. Oh, so I have an error. Okay, Unix epoch now is not defined. I made a mistake. Unix epoch now. Oh, yeah, that's true. Because what it's telling me is like I'm using this variable, but the first time I declare this variable, so the first time I set a value for this variable is in here. So the first time when I get here, this variable doesn't exist. So I have to initialize. And in this case, I'm going to initialize to 0, because as the condition will be smaller than the time that we will be okay until it updates in here. Okay, so just run it. CLS. Okay, 1, 2, 3, 4. I don't know now if, yeah, it's printing. 7, I think. 8, 9, 10. Okay, and it stopped. If we just set in here, oops, sorry. True, while true, so then we will have an infinite loop, and this will be running forever. 4, 5, 6, 7, 8, 9, 10, 11, and we'll continue. Will not break because this condition is always true. So it will be executing. It will execute all of this. We'll come here, execute this, and come here again and evaluate this is true. Okay, I will continue. So in order to stop that, we will press, we'll press Control C. Control C will break the loop. So it's a keyboard interrupt. So that's basically how we use the time as a counter. So we took advantage of one of the libraries that we had. There are many ways to achieve the things when programming, and that's really cool. So for example, we can, instead of using the time, we can say, okay, 3 counts, we are gonna say 0. 3 wanted. We want to print 3 times the trees. So what we are gonna do is while, so as long as the number of 3 counts is smaller than 3 wanted, then you will do this. So print and sleep. We don't need this anymore. I'm gonna comment it. So it's not executed. Or just to make more clarity, as you can repeat the video, I'm gonna just delete so you see the code more clear. Okay. This is a warning that the I does, this green here. It just says that according to PIP 8 standard, I should leave 2 lines. That's not something that will make the code fail, but it's something that it's something for style, simply for style. Yeah, now it has not updated because sometimes it's a bit slow. It works in Java, and it requires time. So 1, 2, we have 2 lines, and should we have notice? Okay. So now this will run forever as well because the 3 counts is never updated. So what we have to do is to update it. 3 counts equal 3 counts plus 1. So now it has updated. After each loop, it will update the number. So on first time it will be 0. It will get here, will be 1. We'll evaluate 1 is less than 3, yes, so do again. Will be 2 in here, will be evaluated. Is 2 less than 3, yes, so repeat. And here will be 3, and we will evaluate is 3 smaller than 3. It is not, so it will continue. So just show that. 1, 2, 3. Okay, it finished. If we say 5, it will do 5. 1, 2, 3, 4, 5. Okay. So, and we can also add here print iteration number, and then print the variable i3 counts. So we will have 0, 1, 2, 3, 4. Okay, 4. We have many ways to achieve the same, so probably it's more nice to start from 1. So we are going to start from 1, but in order to this to work, we have then to add an equal, because otherwise when we have like 5, when this becomes 5, we will evaluate and 3 counts 5 is less than the 5 that we want. No, it's not less, so it will break. So it will have print just 4. But with this, we will have our 5 3s. 3, 4, and 5. That's it. Okay. We can just do something. For example, we can say, okay, if E3 counts, sorry, I will put this on top. If E3 counts is bigger than 3, then we will print a medium 3. In other case, so in the case that 1, 2, and 3, print the small 3. So we are going to change the logic, and we are moving sleep as well after the printing thing. So basically we will see, okay, on the 3 count 1, you print a medium 3. In the 2, you print a medium 3. In the 3, you print a medium 3. On the 4, okay, is 4, oh sorry, I said the wrong thing. So it's a 1 bigger than 3? No. So it will come to the else case. Is 2 bigger than 3? No. So it will come. It's 3 bigger than 3? No. So it will come to else and print a small 3. It's 4 bigger than 3? Yes. So in this case, we will print medium 3 and we will continue. So we are going to show this. Small, 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 and now bigger and bigger. Okay, the medium ones. And that's it. Let's leave it in here.